Good morning, students. This is Dr. Eustace Russell, working as Assistant Professor, the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are seeing the subject called Robot Dynamics and Control, subject code of RA3601 under the regulation of 2021 for the 6th semester for the 3rd year students. For the previous videos, we have completed up to Unit 3. Today we are going to focus on chapter Unit 4 we are going to discuss today, and we will see the syllabus of Unit 4 first, and then we will move on to the topics on that. We will see one by one. So Unit 4 is control of manipulators. So these are the various topics. It is mentioned over here. So main topic we are going to cover in this unit is introduction to manipulator control, control objectives, open loop and closed loop control, linear time varying systems, linearization of nonlinear systems, input and output stability, BIBO stability. Now we will see one by one. Now what is manipulator? Robot manipulator is a mechanical arm consisting of interconnected links and joints designed to perform the tasks such as material handling, assembly, welding, painting, and inspection. So whenever in industries, this robot will act as a real-time applications. Instead of human being, this robot will be replaced for doing such kind of activities such as handling purpose, assembly, welding, inspection, so on and so. So the main objective of this control system is to ensure that the robot moves accurately and efficiently according to the desired trajectory while maintaining stability and precision. Why is control is necessary? To achieve accurate positioning, to maintain desired speed and acceleration, to compensate for disturbances and uncertainties, to ensure safe and stable operation, to improve productivity and efficiency. So in order to control the speed and so normally in vehicle what you will have, normally acceleration, to control that we will accelerate, or otherwise you will reduce the accelerate to control the vehicle. The main thing is will be to control the speed is brake will be applied to decrease the velocity. So in this also the manipulator is needed, that is control is needed. Why this control is needed means to desired speed it should be achieved means this control is needed. For example, in an automobile assembly plant, robotic manipulators must accurately place components with level precision. So that is one important thing, that will be place components with the level precision one. The main components of the manipulator control system. The first is that controller, actuators, reference input, that is the major thing, robot manipulator, sensors, and feedback mechanism. So it is a form like a closed loop system. So whenever there is a task is not performed properly, it is incomplete means again it will go to the sensor part, again it will be come back to the controller, then the process will be started as usual. So this is the working principle. Here it is mentioned the desired position is provided as the input. The controller processes the error between the desired and the output. So there is a variation in between that. The task performing that and the desired input, whether it is achieved or not, that it will be, we will find the difference and it will be again passed to the input. So main control objectives. First in this left hand side of the slide we can see that position control, that is ensure the end effector reaches the desired location accurately, whether we have reached the proper place or not, that it will be confirmed. Velocity control maintains desired speed during movement. The speed will be maintained. Trajectory tracking follows a predefined path over time. So once ever the path is reached or not, whenever the painting some boiler are inside, the robo arm it is using some operation means whether the trajectory part is reached or not, that will be checked properly. Then force control regulates interaction force between robot and the environment. Disturbances, rejection minimizes the effect of external disturbances. Then stability ensures the system remains predictable and bounded. So this exhibit complex challenges. These are the main challenges that is mentioned over in the right hand side. Non-linearity. Robot dynamics involve non-linear relationships among the position, velocity and torque. Joint coupling. Movement of one joint affect other joint. Payload variations. Changing loads alter system dynamics. Friction effects. Mechanical friction introduces uncertainties. External disturbances. Environmental influences of it performance. So this is that open loop system. In open loop system, no feedback information is used to correct it. So it is a series type. Once it is correct or wrong, it doesn't matter. It will form as a linear path. So there is no feedback. There is no suggestion feedback will be there. The characteristic simple design, low cost, fast operation, no error correction. Then advantages is easy implementation because there is no feedback now. There is no sensor part will be there, so this implementation will be very easy. Low computational requirements. Disadvantages is sensitivity to disturbances, poor accuracy. When there is no feedback option is there, means automatically accuracy will not be maintained properly. Example, industrial pick and place operation with fixed repetitive motion. That is input to the controller, to the controlled passes, then output. So here one example also it is mentioned over here. Consider the cloth dryer whose control action is done manually by the operator depending on the wetness of the cloths. Suppose the operator set the timer for 30 minutes. After 30 minutes, the timer will start even after the cloth are wet. So this is one operation is there. In this, we have a one loop system. It is maintained. Timer will be there, heating element will be there, and cloth will be there. So based on that, actual dryness will be attained. So that is one important thing. It will form as a series path. In this closed loop, the previous thing is coming under open loop. Closed loop is nothing but closed loop control uses feedback to continuously compare actual output with the desired output. So this will automatically give a high accuracy, self-correcting. Correction will be there. Whenever we are doing some work, means some feedback is there, means then our work will be in correct accuracy. Otherwise, there will not be any correction, means nobody will follow the work in a correct manner. The same thing will be followed here also, closed loop. Once the signal that is passes, error signal is passes, again it will be corrected and finally the desired output will be reached. That is one of the important thing. So here we can see in the lower side, one feedback option is there, control output, that is, then it will go to the again to the input. This is also an example it is given. The air conditioner is an example of the closed loop system. Air conditioner regulates the temperature by comparing with the surrounding temperature. Normally in our houses we have the AC, split AC, indoor unit, outdoor unit. So whenever the temperature is not occurred properly, what will happen? Again it will, once you are setting the temperature in the remote, that temperature should be reached properly. The 24 degrees centigrade means the room temperature, the temperature inside the room should maintain a 24 degrees centigrade. So that is the important thing that will be maintained in the AC, air conditioning. So in order to achieve the 24 degree, again the loop will be continuous, closed loop system will be followed to reach the 24 degrees centigrade. Otherwise, it won't work. So once the door get open, again the temperature will rise, then the same process will be followed again and again. So this is coming under closed loop. Introduction to linear time varying systems. A linear time varying, that is LTV systems, a system whose parameters change with time but still satisfy the principle of superposition is called a linear time varying system. So this will have the expression that is x dot means it is a differential part of that one, and at, xt plus bt, ut. These are the various terms which we have mentioned over here. State vector, input vector. This state vector also we have seen in the unit 3 also, the last topic. Sorry, in unit 2, the last topic we have discussed as a state vector. So already we have discussed some of the basics in that. So A of t is time varying system matrix. B of t is the input matrix. Then the properties. Parameters vary with the time. Dynamic response changes continuously. more realistic representation of practical systems. Example is robot carrying changing payload, battery powered mobile robots, robot operating under varying environmental conditions. Real time example is an industrial robot lifting object of different weight experiences changing inertia, making the system time varying. Then what is that introduction to non-linear dynamics means? Most robotic manipulators are inherently non-linear only. So this will have the expression. In that expression, we will have m of q equal to inertia matrix, c q dot Polaris and centrifugal forces, g of q gravity forces, tau is joint torque. Why this linearization means robot manipulators are inherently non-linear due to inertia, gravity and joint coupling effect. Linearization simplifies the non-linear model into a linear form around a specific operating point. These are the simplifies. That is stability analysis, controller design, performance evaluation. And these are the various example also it is given. That is x dot equal to f of x comma u, and here some example is for your understanding purpose. Understanding purpose only it is given. Please kindly go through this expression also. The non-linear system is going to operating system, Taylor series suspension, and linear model. Then the stability of control system is also given. Control system is said to be unstable if bounded input produce bounded responses and the system remains predictable over time. Types of stability is given: input, output, BIBO, internal stability. That is input stability is nothing but U of t less than m, and output will be less than n. BIBO stability again similar to that one, input stability, the same thing is declaring. Infinite constant is taken as m and n. So these are the various references which I took to prepare this content. So thank you students, kindly go through the video, subscribe the video, share to your friends. So one of the major topics in unit 4 we completed now. In the upcoming classes we will see the next topics in the same unit, unit 4. Thank you students.